Hi everyone, and welcome back. In today's video, we're going to be learning all about arrays and collections. So in programming, we often need to store multiple values of the same type. For instance, maybe we wanted to store all the fruits in the world just in one variable. We're going to cover a few ways to store different values, including arrays, lists, and maps. Each of these structures have their own strength, so let's start to go over them together. Now, arrays are the backbone behind things like lists and maps, and they're really useful. So if we see down below, we see int, open brackets, close brackets, equals open curly braces, 1, 2, 3, 4, and 5, and then close braces. This is both similar and really different to how we define normal integers. By saying int, we're declaring we want to store an integer value. By putting the open brackets and close brackets after it, we're just telling Java we want this integer variable to be an array. We then define the variable name in the assignment operator, and all we're doing in the curly braces is defining all of the values we want to store in it, separated by commas. Something I note about arrays though is that the index starts at 0. So instead of saying, oh, let's go to index 2, that'll be 2, okay, let's go to index 4, that'll be 4, we instead count up from 0. So index 2 would actually be 3, index 0 would actually be 1, etc. And it's really important to note that when arrays are declared, you can't change the length of them or what's in them. This is going to take some time to get used to and why this happens and when, but let's go ahead and go into IntelliJ and see if we can get some practice in with this. So we're going to go ahead and define all of the fruits. So we're going to say string, and then we define it as an array with the open and close brackets. We're going to name it fruits is equal to open curly braces enter. I'm going to say banana, orange, apple, let's do kiwi, and grapes. Then we add a semicolon after the closing curly braces. And so now we've defined an array. Now it's also possible to have all of this on one line like this here. I just find it a lot more clean if it's on multiple separate lines. And Java really doesn't care about space or indentation. Just make sure you don't add space between, for example, variable names or anything like that. So this right here is going to be fine. So let's go ahead and print out all the values. So a shorthand to doing system.out.println here is we can actually just, at least in IntelliJ, type sout. You're going to see this autocompletion here, sout, print a string to system.out. If we hit enter on that, we're going to see it automatically fills in system.out.println. It's just the shorthand. So let's go ahead and print out the fruits.length. So if we run our current file, we're going to see down here, when this decides to run, 5. Because we have 1, 2, 3, 4, 5 things in our fruit array. Now, let's go ahead and print out each of these values. We can go ahead and do that by removing this .length and printing out, for example, the value of 1. So what we learned earlier is that arrays start at 0 instead of starting at 1. So if we decide we want to access index 1 of this array, what do you think that's going to amount to? If you said orange, you're right, because it starts at 0. So another cool thing about Java is that we can actually define comments too. We can do that with 2 forward slashes, so // and then we can just put whatever value in here we want. I'm going to put 0, go down to the next line, 1, go down to the next line, 2, 3, and 4. I'm actually going to put a space here. Now, comments are something that you don't need to put in your Java code. If I run this now, the output is not going to change, even if we wanted to put something like a comma and just put random characters in there, the output's not going to be changed because Java is just ignoring these comments here, and those are just for us. We can also define multi-line comments by doing /*, then it'll autocomplete it with a //. We can put multi-line comments on here like this is a multi-line comment, and again, the output's not going to change here. But I'm going to remove this one here. And so if we're printing out the index array of 1, we can see our key here. 1 is equal to orange. So let's go ahead and print out all of these values. So I'm going to do it with a for loop that we learned a few lessons ago. So for int I is equal to 0, if I is less than fruits.length, I'm going to increment I by 1. Then I'm going to say sout fruits and then the index of I. Since, for example, if I starts at 0, our array starts at 0. So, for example, when I finally reaches 3, we're going to see kiwi. So we can just access the index array of I. So now if we run this, we're going to see all the things in our array here. So you're also going to see this yellow underline under the for loop. If we hover over it, we can see for loop can be replaced with an enhanced for loop. Enhanced for loops are almost a cleaner way of doing this. So instead of saying int I is equal to 0, I is less than fruits.length I++, we can just say, we can make a new variable in here called string fruits out of, with a colon, out of fruits, and then instead of here, we can just print out fruit. And this is going to go ahead and automatically, for each fruit, do the same exact thing. For each fruit out of the fruits array, it's going to print out that fruit. So if we run it, we're going to see the exact same thing, but in my opinion, a much nicer way of doing it. So we talked about arrays, but here with array lists, they're a dynamic array that can both grow and shrink. We see an array list, less than, string, greater than, names is equal to new array list, less than, greater than, parentheses, whatever. All this bit is doing is defining an empty array that has nothing in it. The syntax for this is kind of complicated, but whatever is inside the less than, greater than signs is the type. For example, here we're passing the type of string, but you could also pass it in a type of integer or double or really whatever you want. So next we're going to add vegetables to the list. We're saying names.add carrots, names.add cabbage, etc. Along with adding things to the list though, we can also remove them. So if we wanted to remove broccoli, if the index starts at 0, 0 is carrots, 1 is cabbage, and 2 is broccoli, just go ahead and pass in the index of 2. Let's just go into IntelliJ and see if we can actually use these. So I'm going to go ahead and modify our fruit array here to use an array list. So to do that, I'm just going to delete this up here. I'm going to say array list string fruits is equal to a new array list. So you're going to see here IntelliJ automatically added import java.util.arraylist for us. All this is doing is since ArrayList isn't part of the default Java language, we're going to go ahead and import this that is from Java, but it's not in the actual language. If we did not have this here, it's going to add it anyway, but if it wasn't there, we would get an error saying that ArrayList isn't defined since we don't have this import. I'm going to then say, let me actually just remove this print here. We'll then say fruits.add banana, semicolon, fruits.add orange, fruits.add kiwi, fruits.add grapes, and finally fruits.add apples. I'm going to go ahead and do our comments again. So this starts at 0. This is 1. This is 2, 3, and 4. So now we know which is which. I'm going to go ahead and space this a bit out so it's easier to read. And so now if we run this, we're going to see the exact same thing again. It's going to print out all of the fruits in our fruits array list. So what we can also do now is we can say fruits.remove the index of 2. The index of 2, thanks to our comments, we can see is kiwi. So when it prints them out, we're not going to see kiwi. So we're just going to see banana, orange, grapes, and apples. Another thing we can use are just called lists. They're almost identical to array lists, and we'll be mainly using them from now on and in the Minecraft client since they have more flexibility than array lists do. So let's go ahead and redefine this. All we have to do is instead of saying array list here, just say list. We don't have to change this new array list since the list is a subset of array list. So if we now run this, we're going to again see this exact same thing. So Hashmaps are a collection that can store key value pairs. So maybe you want to store the grades of a student, let's say. We can define that with a hash map. The key being a string and the value being an integer. The key is what we'll call whenever we want to access the value. We can use the .put function to put something in the hash map and use .remove to remove it. Notice though for the remove and get methods, we have to pass in the key since each value is assigned a key. Let's go into IntelliJ and just see how to do this. So I'm going to go ahead and just remove all this here. Then I'm going to say hash map. We're going to see if we press Command P or Control P, K extends object, V extends object. Now this extends object just means we can pass in anything. So if we just pass in a string and a string here, and say foods is equal to new hash map. All right. And then if we say foods dot put strawberry, and then the value we can put in fruit. So the key is strawberry, that's the first one, and fruit is the value. Now, if we wanted to make this maybe an integer here, we would have to define that with an uppercase I and the full integer name. We don't have to do anything special for string because it's already like that. Double would be the same thing, double, float, etc. So really, you just have to put in the full name with the first one uppercase. It's a bit weird why Java does this, I'm not gonna lie, but it's just one of those things you have to get used to. So I'm gonna change this back to a string. All right, so I'm gonna just copy this down a few more times. And then I'm gonna say broccoli, steak, apple, and chicken. Broccoli is a vegetable. Steak is a meat. Apple is a fruit, and chicken is a meat. So now if we come over to this for loop here, I'm just gonna remove this for now, and I'm gonna say for string key out of foods.keyset system.out.println. I'm gonna say key is a plus foods.get and then key. And now if we print this out, we're going to see apple is a fruit, chicken is a meat, broccoli is a vegetable, steak is a meat, and strawberry is a fruit. Now, you're also going to notice that these aren't in the order we put them in, and that's just kind of a weird thing about Java. It just kind of reorganizes them how it wants to for performance, but it's not something to worry about for now. So in IntelliJ, we saw that we have the same string for multiple different food types, like fruit, vegetable, and meat. So what if we were able to make something that could store those for us, so we didn't have to rely on strings that we could, for example, make a typo on? Well, we can. They're called enums. Let's just go back into IntelliJ and see how these work and how we can use them. So the first step here is on the left-hand side. Let's expand this up. In the lowest class here, for me, it's source main java asnos. So in the asnos package, I'm going to make a new Java class. If I go down here, I'm going to go down till we see enum. And I'm going to type in here food types. Now you're going to see a new class up here, public enum food types, in our package name up here. We don't though have to put in public static void main, since Java is already able to infer that this is our main class. So in here, I'm just going to put in vegetable, comma, fruit, comma, and meat, semicolon. This is all an enum does. It just stores values. We don't have to put in any fancy code here. Now, what an enum does is it really just stores constant variables that you know aren't really going to change. So, hence we're making all of these uppercase like constants are. If we go back to our main class here, in the foods.put strawberry fruit, I'm going to remove this string and put in food types dot fruit. We're going to get an error here because it's requiring the string and we're providing a food type. So in this value here, I'm going to put in food types. And now I'm going to change the rest of these. So food types dot vegetable, food types dot meat, food types dot fruit, and finally food types dot meat. So now if you run it, we're going to see apple is a fruit, chicken is a meat, broccoli is a vegetable, etc. Now you're also going to notice that these are all uppercase. That isn't very fancy. So what we can instead do is we can actually define a display name for these. So down here, I'm going to write final string display name, and then I'm going to put in food types string display name, and then this dot display name is equal to display name. And then after these food types here, I'm going to put in parentheses and then put in quotation marks and just type the human readable version of this. So vegetable, fruit, and meat. Now this looks pretty complicated. So let's go ahead and see how this works. So final string display name is saying we want to make a variable display name that's final, so it never changes. And then here we're saying food types, which has the same exact name as our public enum food types. as our public enum food types, and then as arguments or parameters in here, we're saying we want to accept a string of display name. And then we're saying this.displayName, which is this line here, is equal to this display name that's passed in the arguments. And then, since we have a string display name here, we have to provide it a parameter. So in the vegetable, we're providing it the parameter of vegetable, fruit of fruit, and meat of meat. Now, it's okay if you don't understand this fully. That's something we're covering in the next few lessons. And then if we go back to our main class, we can use the display name by after foods.getKey, we can just type .displayName. So now if we run it, we're going to see apple is a fruit, chicken is a meat, broccoli is a vegetable, steak is a meat, and strawberry is a fruit. So with all these different types of storing data, it might be confusing on when to use what. First of all, we have arrays. These have a fixed size, good for when you know exactly how many items you need to store, and that number will never change. For example, storing the days of the week. You're always going to have 7 days. Now, list and arrays are best used when you need a flexible container that can grow or shrink at any time, like storing how many players are connected to a Minecraft server. Maps are best used when you need to store key value pairs, like maybe we have a player name as the key and their UUID as a value. So when we want to know the player's UUID, we can just look the player up by their player name. Enums are used when you have a fixed set of related constants you might want to group together, so maybe you're storing all of the items in Minecraft, so each item would have its own value associated in enum. So that about wraps up this video, but before you go, I want you to do a challenge on your own to make sure you can understand most of this. I want you to make a to-do list application. When you type a string in the terminal, it'll add that string to some sort of variable, and when you type the keyword list, it's going to list out all of the current things in that list, and if we type out exit, it's going to exit the program. So here's an example of what should happen in the terminal. I'm going to give you a few seconds to pause the video, and if you can't figure it out, I'm going to give you a hint. So the hint is, you're going to want to store the to-do list in list. We don't want an array or enum because we can't modify the values. We don't want a map since we don't need a key value pair, so hence we're only left with the list. I'm going to give you a few more seconds to pause it before we go over the solution together. So I hope you were able to get that. If you had any trouble or need help with something, you can try asking me in the comments. Or if you have an error, try and revisit the last episode on how to solve your errors and debug your program. Let's go ahead and dig into the code. So we're making a list of type string of to-dos is equal to a new array list. We're then defining a scanner. We're then saying welcome to the to-do list application. Type out something to add to your to-do list. So while true, since we want the program to run forever, we're taking in a string of input. If that input is equal to an ignore case list, we're going to print out all of the to-dos. Now, you've probably never seen an equals ignore case before. This is the same thing as saying if input is equal to list dot to lowercase. So we can go ahead and modify this by saying if input dot equals list dot to ignore case. That's going to do the same thing. But if we instead want to have any case here, we can just remove this and say equals ignore case. And that's going to give us this exact same result, just in a more efficient and cleaner way. So then we're going to print out all of the to-dos here by going for string to-do out of our to-do list. Let's print out the to-do. Else, if the input equals ignore case exit, we're going to print out goodbye and type break to break out of the while true loop. And else, if they didn't type list or exit, we're going to add the input to the to-do list and say we added it to the to-do list. So if we go ahead and run this, we can see, let's type in maybe buy grapes. We're going to see added buy grapes to the to-do list, get milk. So now if we say list, we're going to see buy grapes, get milk, and if we type in exit, it's going to quit the program. So that's going to wrap up this video. Please like and subscribe if you found this useful since it really helps the algorithm. In part 7, we're going to talk all about methods.